I want you to picture a scenario. And I think every single person listening has probably experienced this, or at least they fear it. It's 3 in the morning. You're on call.
Oh, no.
And your phone just screams,
Yeah.
a critical server has gone down. Now, in the old world, let's call it the legacy era, you are dragging yourself out of bed, you're logging in, frantically digging through logs.
The dreaded pager duty nightmare. Yeah,
Yeah.
it's a rite of passage, but a painful one.
A very painful one. Now, imagine that same 3 a.m. scenario, but you stay asleep. The system itself detects the failure. It terminates the unhealthy instance, spins up a fresh clone from a golden image.
And just handles it.
It handles it. It verifies it's accepting traffic, updates the load balancer. You only find out about it over coffee the next morning when you see a notification that says, severity 0 auto-resolved.
And that is the fundamental difference. It's between maintaining infrastructure and actually, engineering it. And frankly, if you aren't aiming for that second scenario, you're playing a losing game.
That is the absolute core of what we're unpacking today.
Yeah.
We've got a stack of notes here from a Cloud Practitioner session. It's dated January 19th, 2026. The theme is AWS Automations and Managed Services. And the mission statement in these notes, it's remarkably simple. Doing less to do more.
I mean, it's a catchy phrase. It almost sounds like marketing fluff, doesn't it?
Mm-hmm.
But when you actually look at the source material, it's a rigorous technical philosophy. We're looking at moving away from all that undifferentiated heavy lifting.
Plumbing.
The plumbing, exactly. So teams can stop fixing pipes and actually focus on shipping features.
We've got so much to cover here. We're going from the database landscape to container orchestration and eventually serverless. But I want to start with this concept of the force multiplier. It's mentioned right at the top of the notes.
Right. The force multiplier effect. This is so crucial because, often management hears automation and they just think layoffs. But the notes here, they frame it as rapid changes and improved productivity. Think about it. If you have a team of 5 senior developers and they spend half their time patching servers or manually configuring firewalls, you really only have 2.5 developers.
So automation isn't just about speed. It's about capacity recovery. You're literally getting your brain power back.
Precisely. If you automate the deployment pipeline, suddenly those 5 developers are doing the work of 10. You remove that human bottleneck of, oh, I need to wait for Dave to get back from lunch to configure the security group.
The notes also highlight repeatable configurations as a major pillar here. They specifically mention CloudFormation. Now, for anyone who's uninitiated, we're not just talking about a checklist on a wiki page, right?
No, and that's a vital distinction. We are talking about infrastructure as code, IAC. The notes use these terms, modularity and reusability. Think of it less like a cookie recipe and more like, a factory mold.
Yeah.
If you build a server by hand, clicking through the console, that's an artisan craft. It's unique. And in this world, unique is actually bad.
The snowflake servers.
Exactly. You don't want snowflakes, you want Lego bricks. With CloudFormation, you define your entire infrastructure in a text file, JSON, YAML, whatever. You press a button, AWS builds the environment. You press it again, it builds an identical copy in another region. It just eliminates the, well, it worked on my machine excuse.
Because the machine is defined by the code.
The code, not by whoever set it up last Tuesday.
Which dovetails really nicely into the fourth point in the notes, elasticity and auto-scaling. This feels like the classic cloud promise pay for what you use, but the notes frame it as an automation benefit, not just a billing feature.
Well, because without automation, elasticity is just theoretical. You can't have a human watching a dashboard 24/7 waiting to add more RAM when traffic spikes.
Of course not.
The automation rules, if CPU is over 80% for 5 minutes, add 2 servers, that's what makes elasticity real. It turns the infrastructure into like a living organism that breathes in and out with demand.
And it keeps the CFO happy, so you're not paying for Black Friday capacity on a random Tuesday in March.
That too, yeah. Cost optimization is a massive driver.
The final pillar mentioned is automated testing. The notes reference tools like Code Pipeline and Code Build.
This is the safety net. In a manual world, testing is, let's be honest, it's often the first thing that gets cut when deadlines are looming.
We'll test it in production.
Famous last words. With tools like Code Pipeline, the testing is literally the gatekeeper. The code cannot go to production unless it passes the whole automated test suite. It enforces quality systematically, not culturally.
So you don't have to nag people. The robot does it for them.
Exactly.
So that's the philosophy. Let's get into the actual tools, starting with where the data lives. The notes draw a really sharp line between Infrastructure as a service databases and managed ones.
This is the distinction between leasing a car and taking a taxi.
Okay, break that down for me, because I think a lot of people still default to the old way just out of habit.
So if you spin up an EC2 instance and install MySQL on it, that's the old way. You are the mechanic. You handle the OS patches, the database updates, the backups, replication.
All of it.
If the disk fills up at midnight, that is your problem. You have full control, sure, but you also have full liability.
And the managed way, the RDS approach, relational database service.
You're just the passenger. You tell AWS, I need a MySQL database this big in this region, and they handle the patching, the backups, the failover. The engine's the same, but the operational burden just vanishes.
The notes lift a whole smorgasbord of engines here. Aurora, MySQL, Postgres, MariaDB, even the heavyweights like SQL Server and IBM DB2.
And Oracle. Don't forget Oracle. The notes specifically mention a bring your own license or BOL option for them.
Why highlight that specific detail? What's the big deal?
Because enterprise licensing is a nightmare. I mean, companies have often spent millions on Oracle licenses locked into these multi-year contracts. They don't want to double pay just to move to the cloud. BYOL lets them port that investment over.
So it's a friction remover.
It's a huge friction remover for enterprise migration. It tells them you don't have to throw away your sunk costs to get modern.
Okay, so RDS is great for your rows and columns, but the notes get really interesting when we step outside that relational box. First up, DynamoDB.
The speed demon. Key value storage. If RDS is a library with a really complex filing system, DynamoDB is a massive wall of lockers. You have a key, you get your object.
Simple as that.
It's built for massive scale and single-digit millisecond latency. You're not using it for complex analytics. You use it when you need to read and write incredibly fast.
But the one that really caught my eye, and the notes spent a good amount of time on this, is Amazon Neptune.
Yes, graph databases. This is where the practitioner notes get very specific.
The use cases listed are just fascinating. Fraud patterns, IT security, relationship modeling. My question is, why can't we just do this in SQL? I mean, we have foreign keys, right? We can link tables.
You can, but it's mathematically painful. Relational databases are great at listing things. They are terrible at traversing deep connections. If you want to ask who is the friend of the person who bought this item, in SQL, that requires multiple joins.
Which gets slow.
Incredibly expensive and slow as the data grows.
And Neptune.
Neptune treats the relationship itself as a first-class citizen. It's built to navigate these webs of data. The notes mention open source intelligence and fraud detection. Think about a sophisticated fraud ring. It's almost never one person.
Right, it's a network.
It's a shared credit card linked to a shared IP address, which is linked to a shared shipping address, which is linked to a totally different account.
So it's not looking at just the transaction in isolation.
Exactly. Neptune connects those dots almost instantly to reveal the shape of that network. It sees the web, not just the spider. If you tried to run that same query on a big SQL database, it might just time out. Neptune gives it back in milliseconds.
Okay, let's move up the stack. We've got our data stored. Now we need to run the application code. And this is where the notes dive into containerization. This section is a bit of an alphabet soup. ECR, ECS, EKS.
It confuses everyone, but if you strip away the acronyms, it's really just a supply chain.
Let's start with the warehouse then. ECR, Elastic Container Registry.
Right. Before you can run a container, you have to build it and store it somewhere. That's the registry. You write your code, you package it up as a Docker image, and you push it to ECR.
The notes mention the standard stuff compressing, encryption, tagging, but then they highlight vulnerability scanning.
And this is the killer feature.
How so?
In the old days, security was basically a firewall you put around the server. With ECR, when you push an image, AWS can automatically scan the operating system packages inside that container against a huge database of known threats, of CVEs.
So wait, before the code even runs, AWS is telling you, hey, this version of Linux you've packaged has a known backdoor.
Exactly. It's catching security issues at the storage layer before they become runtime issues. It's the very definition of shifting security left.
Okay, so the image is safe. It's sitting in the ECR warehouse. Now we need to run it. And we have two choices for orchestration, ECS and EKS.
The manager versus the standard.
Let's start with the manager. ECS, Elastic Container Service. The notes say it has deep integration with IAM and works with Fargate.
ECS is basically AWS's opinionated way of running containers. It's designed to be simple. If you are all in on the AWS ecosystem, ECS is usually the path of least resistance. It integrates with the load balancers natively. It understands AWS security roles perfectly.
So then why does EKS exist? Elastic Kubernetes Service. The notes sort of imply it's harder to tame.
Because the entire world kind of decided on Kubernetes as the universal language of cloud infrastructure, EKS is fully managed Kubernetes. The number one argument for EKS is portability.
The notes mention hybrid and multi-cloud deployment.
Right. If you write your application for Kubernetes, you can theoretically run it on AWS, on Azure, on Google Cloud, even on your own servers, with very few changes. You're not locked in to the AWS way of doing things.
And there's a specific call-out here to EKS anywhere.
That's the bridge. It lets you use the AWS EKS console to manage clusters that are physically running on your own hardware in your own data center.
Wait. So I can use the cloud control plane to manage my on-prem servers.
You got it. It brings the cloud operating model down to the ground. It's huge for industries that have, strict data residency requirements, but they still want all the modern tooling.
So the rule of thumb seems to be ECS for simplicity and deep AWS integration, EKS for industry standards, and hybrid flexibility.
That's a pretty fair summary, yeah.
Now, if containers are about packaging the application to run anywhere, this next section is about, well, exploding the application into tiny little pieces. Serverless compute. AWS Lambda.
My favorite topic. This is where the paradigm really, really shifts.
The definition in the notes is just execute code in response to events.
It sounds so dry, but it's revolutionary. Traditional computing is, I have a server and it waits for a request. You pay for it while it's just sitting there waiting.
Right.
Lambda is, an event happened, now spin up some code to handle it and then die.
The notes have this really interesting observation, sort of like AWS NAN as a trigger and action system. For those who don't know, NAN is a workflow automation tool.
It's a great comparison for this audience. It highlights that Lambda is often the glue of the internet. It's totally event-driven. A file lands in S3, that's an event. Trigger Lambda. A user updates a database row, event, trigger Lambda.
An IoT sensor sends a signal.
Trigger Lambda.
The laundry list of use cases here is massive. I want to pick a couple just to make this more concrete. Real-time file processing really stands out.
Okay, let's walk through that. Imagine you're building a media app. A user uploads a raw 4K video. You need to transcode that for mobile, create a thumbnail, maybe run some AI moderation on it.
In the old days, I'd have a fleet of processing servers running 24/7, just waiting for uploads.
Burning money while everyone sleeps. With Lambda, you just configure a trigger on the S3 bucket. The moment the file lands, AWS spins up a Lambda function, does the work, and shuts down. If one user uploads a video, you pay for one execution. If 1 million users upload at the same time,
AWS spins up 1 million functions instantly. And you didn't have to configure an auto-scaling group.
I didn't even have to know what a server was.
Automated DevOps tasks is another one listed. The notes mention CR on jobs.
This is the classic janitor use case. Let's say you want to shut down all your development servers at 6 p.m. every Friday to save cash. In the past, you'd have a dedicated server just to run that scheduler.
Which is pretty ironic, right? Keeping a server running just to turn other servers off.
Exactly. Now, you just use EventBridge to trigger a Lambda function on a schedule it costs fractions of a penny to run.
It's the ultimate doing less to do more. You focus entirely on the logic, the if this, then that, and AWS just handles all the compute.
And because it integrates with over 200 services, like the notes say, you can stitch together these incredibly complex systems without ever managing a single operating system.
We can't wrap up without talking about where all this data actually lives. The vault. S3.
Simple storage service, the backbone of the modern web, really.
The notes call it object storage for unstructured data. But I want to focus on the security section because there's a bit of history here.
You mean the leaky bucket era?
Right. The notes explicitly state, public access is set manually. All buckets are private by default.
This was a major shift by AWS a few years ago. In the early days, it was a little too easy to accidentally make your corporate backups public to the entire internet. We saw headlines about it constantly.
We did.
Now, AWS forces you to be intentional. The block public access setting is on by default. You have to actively turn off the safety protocols to make something public.
And you control that with bucket policies written in JSON.
Which are incredibly granular. You can say, only this specific user from this specific IP address can read this specific folder. It's not just open or close. It's a very precise dial.
The notes also mention bucket versioning. They compare it to GitHub. Turn it on for rollback.
This is your insurance policy against ransomware or, rogue employees.
So how does that work in practice?
If versioning is on when you overwrite a file, S3 just keeps the old one. If you delete a file, S3 just puts a delete marker on top of it. The data is still there underneath, so if a hacker gets in and encrypts your data, or a junior dev accidentally runs a delete script,
You can just hit undo.
you can roll it back. Yeah.
And combining that with all the encryption options, server-side encryption, KMS, it really is a fortress if you configure it right.
That's the key, if you configure it right. But the defaults are much, much safer now than they used to be.
So let's just zoom out. We've gone from the force multiplier of automation through managed databases, container registries, all the way to serverless triggers.
It's a complete shift in how we think about IT architecture.
It brings me back to that mission statement from the beginning, doing less to do more. But looking at all of this, the auto-scaling, the managed patching, the serverless execution, it raises a kind of provocative question for me.
What's that?
If the infrastructure manages itself, if the database heals itself, the registry scans for vulnerabilities, and the capacity just scales without us touching anything, what is the role of the human in 2026?
It's a valid fear. I think a lot of ops people look at this and see their job descriptions just evaporating. But I think the notes point to the answer. The human stops being the maintainer and starts being the architect.
So we stop digging the ditches for the plumbing and we start designing the skyscrapers.
Exactly. The complexity hasn't gone away, it's just moved up the stack. The business logic is more complex than it has ever been. The value of a cloud engineer today isn't knowing how to patch Linux or configure a RAID array. It's knowing how to stitch Lambda, Neptune, and S3 together to solve a business problem that was impossible 5 years ago.
So the automation isn't taking the job, it's elevating the job. It's demanding that we understand the whole system, not just the little components.
And that is both exciting and a little terrifying. It means your value isn't in what you can fix, but in what you can design.
A challenge for all of us to level up.
Absolutely.
That's a wrap for this deep dive into AWS automations and managed services. Thanks for listening.
Until next time.